Welcome. It's great to be here in Seattle, and I'm glad so many of you have taken your time to come here and listen to us talk about an old movie. Actually, this talk isn't about that movie, so if anyone thought so, they may leave now. Yeah. Thanks. Okay. My name is Jorgen, and this is Pedro, and we are working in the delivery team in a Norwegian company called Schibsted. Schibsted, I'm gonna just shortly tell you a bit about the company. It's a Norwegian multinational company. It has about 7,500 employees. Spread all around Europe and Southern America mostly. In the Nordics, it's mostly known for owning a couple of newspapers, and in the rest of the world, we are owning online marketplaces. Like we are not owning Craigslist, but similar online marketplaces like that. We have a reach in Norway and Sweden about 70% of the population each day, so it's actually bigger than Facebook in that regard. And we have almost 300 engineers that are using Spinnaker internally in the company, and we are a team of 4 people that are managing and contributing to the Spinnaker codebase. So that's Schibsted. I'm going to go through some history about Spinnaker and Schibsted. So we started testing Spinnaker in 2015. And we rolled it out for our users in the first half of 2016, I believe. And the reception was really good, amazing, really. But as we onboarded more and more teams, we started experiencing some growing pains. And while we tried to provide guidelines for best practices and stuff like that, we didn't enforce anything. And our users there created a lot of pipelines that ranged from really, really cool to, frankly, pretty bizarre. We, as the team that are managing Spinnaker, we really saw a need for having some kind of control, and declarative pipelines was one way of doing that. And at the same time, that was also the #1 requested feature by our users. And it actually got to the point that because Spinnaker didn't have this feature, engineers working in other parts of Schibsted, they started doing this themselves. They created CLIs and they started abusing the Spinnaker API in ways that was not endorsed by us and without any safeguards at all. So it was kind of messy and not really good. So at the time when the DCD or the Declarative Continuous Delivery or the Managed Pipeline Templates feature was announced, we were early adopters in our company. And that has been a really bumpy ride with a steep learning curve, and in this presentation we will talk about what we have learned. So, short about Managed Pipeline Templates. It goes by many names, but it actually means the same thing. It's Declarative Continuous Delivery, Managed Pipeline Templates, Pipeline as Code, basically the same thing. And I'm not sure we are going to be, I'm sure I'm going to switch a lot of the terminology in this presentation, so bear with me. So I'm not sure if all of you have been introduced to these pipeline templates, but on the left here you can see a very minimal template. It's At the top, it's just some boilerplate, naming, descriptions, and stuff like that. Then there, in the middle there, it declares one variable. And at the bottom, you can see a single stage, which is a wait stage. So, and that uses the parameter you have defined in the middle. So, really, really simple. And you can see that it's YAML. So all pipelines are declared in YAML. All the templates, I mean, are declared in YAML. And the structure is similar, but not identical to the internal JSON structure you can find in Spinnaker. It supports templating by using Jinja. And that's the one you can see at the bottom, where you see the wait time and these double curly braces. This is Jinja, and it will just replace that with the value of wait time. It also supports spell, which is the we have written Spinnaker expression language, but it's actually the Spring expression language with some added bells and whistles. And if you see the default value here, on almost at the bottom, that's spell. So you're probably familiar with that from Spinnaker. Okay, now I'm going to leave the word to Pedro. He's going to talk about the first part, which we have called the good.
All right, thank you, Jorgen. So as you probably noticed by the title of our presentation, it's the good, and then there's the bad, and the ugly. And Jorgen mentioned we had some experience with declarative pipelines. A lot of it's good and very positive, but steeping learning curve. So let's start with the good. This pipeline that you're seeing there, it's actually a full-fledged pipeline that a lot of our users can use. And you probably see that it's quite minimal, and that's because we love inheritance. So notice this little part here, the source. It's inheriting from a master template pipeline that we, the Spinnaker team, maintain. And that's because creating declarative pipelines, these templates can be quite complex and difficult. So we come up with a strategy where we abstract all that complexity from the user, and we just tell the users to create child pipelines that inherit from this parent pipeline. And we try to solve the typical 80% of the cases. Let's say that most of the users, most of the deployments of applications, they are fairly similar. So we created the parent pipeline that kind of mimics that sort of traditional pipelines, and we allowed our end users to replace some of the variables, giving more behavior to their child pipelines. This one is a very basic one. It's the minimal possible for in our setup. And what this will do, it will create a pipeline with 3 stages: deploy to development, deploy to pre-production, and deploy to production. All these 3 deployments with pretty much, 7, 8, 9 lines of code. The only thing that we actually need to specify is the namespace, and this is the namespace for the Kubernetes, because this is a deployment to Kubernetes, the namespace of your Kubernetes. Right? So let's continue a little bit more. As you can see, this parent pipeline, it will unfold into 300 lines of code of this parent pipeline that we, the Spinnaker team, maintain. And that's all. That complexity is all hidden from the end user. It doesn't really need to know much about it. Okay, we can see in here how this minimal template, once one execution starts with the pipeline, this is how it will look like. Deploy to deploy to pre-production, and deploy to production. And these stages, they actually unfold into 3 substages. This is because of a particularity of our deployments to Kubernetes, where we use abstraction tool in top of Kubernetes. And then in our parent pipeline, we actually do this unfolding using the power of partials in pipeline templates. Let's see a case with a little bit more of behavior. Pretty much the same thing. We added a variable here where we say deploy to pre-production. Well, it's false. I don't care about the pre-production environment. I don't have use for it, so let's just skip it. And as you can see, only 2 stages: deploy to dev, deploy to pro. All of these with just simple override of a variable. There's also other thing in here where you can see some of our users like to run jobs either before or after deploying to a certain environment. So in this case, let's say the user wanted to run a job, a script in Travis to run some behavior before deploying to dev. You can do it very simply with just this overwritten, saying run this Travis job, give it some parameter, and as you can see, there's a hook that will call a Travis job, and then after this hook succeeded, it will deploy to dev. Typically, this is mostly used after deploying to run some integration tests, smoke tests, whatever the user fancies to use, right? Another thing, we use artifact for everything, and this actually includes the declarative pipeline itself. So for this, we added a small customization in deck that we use internally, and which is when the user is initially setting up the pipeline, it will give the name of the pipeline, and you are quite familiar with this, but then it will say the declarative pipeline will come as an artifact, and this is the type of the artifact, Spinnaker pack, which stands for pipeline as code, and then the artifact name. Typically, it will be a pipeline.yaml file, so the name will be pipeline. What this does, and for the ones that are curious about what it does under the hood, is just modify the JSON of the pipeline to search for the specific artifact and add it as a source. This the user doesn't see, but for all of you that might be curious to see what happens under the hood, this is the JSON of the declaration of the pipeline. And what this does, we can see here one execution of the pipeline. Here are the artifacts being used. The Docker container, which is the application actually being deployed to Kubernetes, of course. The path file, as I mentioned, our abstraction on top of Kubernetes. And the pipeline itself, the declarative pipeline, right? And what this allows us is to have very simple rollbacks where if you change the pipeline, the declarative pipeline, and somehow you messed up, you can very easily roll back by triggering a manual execution with the previous build, and you get all the artifacts because everything is versioned, and the application comes together with the path abstraction file and with the declarative pipeline. So everything goes hand in hand, right? Full traceability and rollback capabilities for the application and the pipeline itself. All right, so if you have been in the game of declarative pipelines for a while, you probably have heard about Rower. It's a great tool, but we don't use it. To start with, when we initially started using declarative pipelines, it was really early stages, and there was no Rower, so we just went along in a different path, and we actually came up with this idea of using the declarative pipelines as artifacts. So then when Rower come on board, we evaluated it. It was pretty cool, but it didn't fulfill our needs, so we just choose it not to use it. So version control support, Rower, not really. And as we use the pipeline templates as artifacts, yes, it has full traceability within GitHub. You can see when the declarative pipeline was changed, because the declarative pipeline is just together with the code of your application. Namespace support, so in Rover, if you update a pipeline, a declarative pipeline, it will be visible for everyone. Anyone can use that pipeline, or even actually change that pipeline, which might not be great. In our case, no such thing. The pipeline lives together with the application in GitHub. We don't support, the way that we work, we don't support pipeline validation. That's a cool thing for Rover, but we have been looking into that and how we can add that to our workflow. So shout out to Fias. This is our abstraction on top of Kubernetes. It has helped us to quite a bit in simplifying the deployment. But again, what we are talking about, the way we use declarative pipelines, can be used with the vanilla deployment, Kubernetes deployment manifests. But this tool that we have been using internally, it's open sourced, and it simplifies quite a bit our work. All right, so presented you the good, and I leave up to Jorgen to give you some insights about what's not so good.
Yeah. Turns out that creating a new DSL with full templating support and inheritance and composition is hard. Actually, it's very hard. And while large parts of the specification of the DCD or the MPT feature has been implemented, there are still unimplemented features, and even though they are mentioned in the documentation. So it's usually clear which parts that are not implemented. For instance, the configuration stanza, it's documented pretty well that it's not supported, but that is not always the case. So it's a bit of trying and failing to figure out how to use this. And in the way that MPT is implemented, there are also some bugs that are impossible to solve. There's a Git issue, for instance, on a specific case where a user wanted this string true to be outputted in the JSON, but you can't, because Jinjava will turn that into the Boolean true, no matter what. And there is no way of getting around that. So there's a lot of stuff like this going on, and you can mostly work around it, but it's something to be aware of. There's also some just counterintuitive stuff. So on the left here, you will see a very simple example. It's just a variable, which is a map with two key and value pairs. And in the stages, we are trying to use or print this in the as the value of whatever. And let's have a little quiz, shall we? What will render here? Anyone want to give it a go? If I would guess, I would say it should render foo colon value and then a new line and bar colon value, right? Any one of you guessed this? No? No. Yeah, this is a peculiarity of Jinjava, I think, or Jinja. It doesn't know that you want YAML. It's only taking an input string and massaging it and creating an output string. So you have to tell it that you want YAML. And here it has somehow fed a Java map into toString and ended up with this in some way. It's a rabbit hole. I've been there. Don't go there. The simple workaround for this is that you can just pipe this variable to the JSON filter, which is provided by Jinja or Spinnaker, I'm not sure. because it turns out that JSON maps are also valid YAML, so that works great. So, this is a nice beach. Why did we put this in the bad section? Because this is really nice, right? I think Pete said something about he wanted suggestions for the next Spinnaker Summit, so I think we should probably go here. But seriously, this what we are meaning to illustrate by this is that the current implementation of MPT, or Managed Pipeline Templates, is deprecated and discontinued, and it will not receive any fixes or new features. So what does this even mean? Will it be going away? We are told that it will still be around for a while, but it has been decided that the current implementation is so error-prone and hard to fix, and it's not worth investing more time in. So should you not use it? Well, if you are like on the have a use case where you can solve maybe 80% of the use cases because everything is really similar, maybe you should, but it's worth noting that the current implementation isn't going to be any better. But is there any hope in the horizon? Yes, it is. Look. It will be replaced by MPT version 2. And this will be a fresh take on the MPT, or the Managed Pipeline Templates. And they are trying to do stuff the right way, using lessons learned in the implementation of version 1. And it's currently in the design phase, and we will take a look at this, very brief look at it later in the presentation. So Pedro will take us through the ugly parts.
All right, because it couldn't get worse, or maybe it could. Here we go. So yeah, Jinja and Spinnaker expression languages within the same file, it can render spooky results. And I mean, Spinnaker expression language, it's a beast on its own. So now add the Jinjava variables to the middle of it, and it's well, it's great. Yeah, great stuff. But here's an example, and this is actually not too bad. We have seen probably worse, but it's complicated because the Jinja rendering happens at a different phase at the evaluation of the Spinnaker expressions. So the Jinja rendering, it happens before the pipeline starts, when the pipeline is rendered by Orca before the execution, and the Spinnaker expression language is during the execution of the pipeline. So there's a lot of things that can happen, but there's one thing which is interesting. So another quiz. What will render in there?
An exact expression.
No. But it's a good guess because we have been there also. But I mean, this looks a quite straightforward Spinnaker expression, right? $, curly braces. Give me the stage, which is called deployment environment. That's evaluated at before execution. But yeah, should give me that variable, right? No, it will give me the $. What? Yeah, funny stuff, right? Because these curly braces and hashtag is actually the commenting kind of thing for Jinja. So everything that's after that, it's gone. Jinja is like, yeah, that's a comment, nice. I'll keep it to myself. So yeah, then just like, after a few hours, you'll probably figure out what you did wrong. The workaround. It's not here, but the workaround is just add the space between the curly braces and the hashtag. It will work fine, and Jinja will not care about it anymore. Spinnaker expression language, it will work just fine. Yeah, a space in there. Because sometimes you change the managed pipeline, you pull the trigger, and what? Nothing happens? Yeah, so it's like, I probably messed up. If you are a Spinnaker developer and you have access to the Orca logs, you are in luck, because you can just go and check the Orca logs, and you'll probably see a huge stack trace. Maybe the stack trace will give you a good indication of what's wrong. Maybe it won't. If you are just an end user of Spinnaker, you probably don't have access to the Orca logs. Tough luck. Or sometimes this can happen. Well, it's better than the previous one, clearly. It gives you that the pipeline couldn't render, it's invalid. So, well, that's better. You click on the source, you maybe expect to have some messages in there that can give you a good indication what's wrong. No, tough luck, probably nothing will be there. So again, you're gonna need access to the Orca logs. And sometimes to debug this kind of stuff, we resort to breakpoint debugging. What we do, we fire up IntelliJ, open the Orca project, create a very small unit test, pass it to the whatever template we are working on, run the test, and then put a nice breakpoint in here where we actually process the template, and then go deep into breakpointing by breakpoint. Hopefully you will realize what you did wrong. It might take minutes, half an hour, 1 hour, but yeah, we will eventually get there. But it's still cumbersome, right? So if you are creating a pipeline from the scratch, or if you're actually modifying a fairly complex pipeline, complex or not, sometimes trivial pipelines, it's yeah, funny stuff. So you should like know YAML, easy peasy for the most part. You should have access to the declarative continuous delivery specification. It's a huge help. You probably will need access to the Orca code, open source, so easy peasy. Access to the Orca logs. Not everyone is lucky enough to have that in your production environment, for sure. And you're gonna need time and patience. A lot of it, of both of them. So, as we mentioned, like in the good part, for our end users, we have that little, nice, small, declarative pipeline, which we call the beauty, and it's simple, easy to maintain. But for us, the Spinnaker team, we maintain the beast, that 300 line of code template.
So let's talk a bit about the future. I mentioned MPT version 2. And that's clearly the way forward. But it's currently in the design phase, so it's not done yet. But we don't know everything about this, because but what we have picked up is that it will be based on JSON-net, which is a third-party JSON templating language. And that has support for inheritance and composition built in, so no need to reinvent the wheel. And that will replace Jinja and hopefully make everything a lot easier to understand. It will have a clear migration path from version 1 to version 2. How that will work isn't clear yet. It will have fiat authorization built in, which is great, so that you can't overwrite another template, and you can also protect your pipelines if you want to do that. So, do we have any takeaways? It's managed pipeline templates are solving a lot of problems for us. It's great, but it's really hard to get right, and I wouldn't recommend it if you aren't willing to invest a lot of time in it, and you should probably shield the end users from the nitty-gritty details. But it's great when you have like we talked about earlier, if you have this 80% fits all case, it's really good.